Hello, my ninja warriors. So, we are going to start permutation and combination. Okay. So, this is the fourth lecture of permutation and combination. But you know what? Let me tell you that in the very first lecture, we studied what are the basics of permutation, not basics of permutation and combination, but we only discussed the fundamental principle of counting. So the first lecture was all about fundamental principle of counting. Now, when I talk about the second session was all about learning permutation, and like we didn't even start permutation, right? So if you go and check, we studied the factorial notation, how to count basically the number of zeros, number of exponents, like that. The third session was all about permutation. Third session is when we started permutation, and we just started it. Honestly, we did not dive deep into permutation. Today we are going to introduce combination. Okay, so today's session will be all about combination, and you will be clearly seeing the difference between permutation and combination. Okay, all right. So just quickly, the moment you join the session, you know what you have to do? You have to smash the like button right away. And I can see already Umar has joined, Pritija has joined. Hi Varsha, hi everyone. How is everyone doing? After so long we are meeting, it feels. Okay, so yes, if you are new to the channel, this is my brief introduction. My name is Namrata and I have over a decade of teaching experience in both online and offline. Here are my credentials, and without wasting any particular time, let's start with combination. Okay. Now let me introduce you with permutation a little bit. In the previous session, we spoke about permutation. What is permutation? It is all about arrangement where the ordering matters. Suppose me and Pritija is standing. Pritija is right next to me here. If I am here and Pritija is here, it will be one way. And now if we flip, if I come here and Pritija comes here, are you getting my point? If I come here and Pritija comes here, switch, then it will be counted as a different scenario in permutation. Permutation means arrangement. Okay, but in combination means selection. The another easy terminology, if somebody asks me what is the another term, voice is not audible. What happened, Jakala? Okay, so yes, I was talking about that in combination, the another word for combination is nothing but selection. Okay, selection. So let's understand the what do we say? Let's understand the definition behind combination. Combination, another word I told you, is a selection. Selection of some or all of a number of different objects. That means suppose I have to select 2 things, I have to select 5 things, I have to select 7 things out of 10. Okay, suppose you love chocolates. How many of you like chocolates? Tell me. How many of you like chocolates? Most of you like chocolates, right? Now in the market there are so many different varieties of chocolates available. Can you count? Ma'am, Dairy Milk, 5-star, Kit Kat, Munch, Perk, I don't know, Kinder Joy, then Ferrero Rocher, then Temptations, Bonville. Okay, I am not a chocolate person. I have counted 9. But your mom says that, okay, bring only 3 chocolates. Then you will be like, okay, now what combination I should bring? You'll be like, I can bring Bonville, then Dairy Milk, and then Kit Kat. 3. Another person can say no, that Kit Kat, Bonville, Temptations. Okay, so these are the combinations which you are making. Combinations of 3 out of 10 or out of 9. Okay, so understand here the order of selection is immaterial. Dairy Milk, Kit Kat, Bonville will be same as Dairy Milk, Kit Kat, Bonville. Sorry, I mean the ordering. Dairy Milk, Kit Kat, Bonville. Dairy Milk, Bonville, Kit Kat. Same thing, na? The arrangement doesn't matter. Okay, all right. Like this, consider the 4 distinct objects. Suppose you have 4, A, B, C, D. Okay, now you have to select 3 out of these 4. What will you do? You will be like, ma'am, I will select A, B, C and I will reject D this time. Selecting 3 means what? Another way of selecting 3 is rejecting D, also rejecting 1. So here D is rejected, here C is rejected, here B is rejected, and here A is rejected. So can you see 4 different selections? Are you getting my point, everybody? Yes. So in 4 ways, you can select 3 things out of 4. Okay. So in how many ways you can select 3 things out of 4 things? So ma'am, 4 ways. Okay. So let us be a little more clear. Okay, now if you want to know that, okay, you have to select 3 things. Understand, now this is very important. You should all be able to understand this. Hold on. I should zoom out a little bit. What do you think? Better? Better. Understand. So this is basically 4 things. 4 ways selection, number of ways of selection is 4. Now, number of combination of 4 distinct objects taken 3 at a time is 4 clearly. Now, let's introduce permutation a little bit. Permutation means let's introduce arrangement also now in this. If you introduce arrangement also, so understand, in each selection, suppose ABC you have selected. Now, if somebody tells you that selection to will matter, but arrangement will also matter, so you will be like ABC. You have studied this. Shuffling ABC among themselves will be done by 3 factorial. Shuffling ABD also 3 factorial. Shuffling ACD also 3 factorial. Shuffling BCD also 3 factorial. Okay. So basically it is 4 multiply 3 factorial. 4 multiply 3 factorial. So 4 multiply 6. So answer will be 24. And you know what? You have studied this. NPR. What is NPR? Understand. Now please understand the terminologies. Here NPR means what? NPR means NPR is doing 2 things simultaneously. It is first selecting R things out of N, and second thing, it is arranging also. Whereas understand, NCR, which is combination. NPR, you know, permutation. NCR is combination. That means NCR is selection. Okay. So here you saw that selecting, we just saw selecting 3 things. 3 things out of 4 can be done in 4 ways. Okay, which is equals to 4C3. 4C3 is nothing but 4. But ma'am, I don't know what is 4C3. 4C3 means selection of 3 things out of 4, and manually we calculated the answer is 4. Now understand this. The number of combinations of n distinct objects taken R at a time is denoted by NCR. Okay. So here if you see, what is NCR? NCR is nothing but, see, understand. NCR is selection, right? NCR is selection. So understand it. Let me go back. I told you that NPR is what? Selection and arrangement. So first case, you have ABCD. Okay, you have ABCD. You had ABCD. Understand this very, very nicely. This is nothing but a relation between NCR and NPR. Okay, ABCD. Now if you are just selecting, can you see this? This was pure selection. The answer is 4. That means 4C3 is nothing but 4. That is one thing. I don't know what is the formula of 4C3. I don't know. But 4C3 is 4, that I know. 4C3. The notation 4C3 means selection of 3 things out of 4 and the answer will be 4. That to we know because we have done that. We have calculated it. So this so everybody will agree. Okay, ma'am. Now, over here, permutation. You know what is permutation? Permutation means what? So 4P3. What is 4? What will 4P3 will do? Tell me. Ma'am, 4P3, hold on. You have taught us in the last class. So let us understand. 4P3 will select 3 things out of 4 like ABC and shuffle it also. P means permutation. Shuffle it also. This 4P3 means what? Selection plus arrangement both. Okay. So 4P3 will be selection. Selection is what? 4C3. And arrangement. What is arrangement? Arrangement means this is arrangement. Understand? This is arrangement. Arrangement of 3 things. So this is 3 factorial. So now I will be writing a formula. Okay. NPR is nothing but NCR into R factorial. And you will find me using NCR into R factorial quite often. Rather than directly doing NPR, I to prefer doing NCR into R factorial because it is very much visible that what exactly you are doing to me. Okay. So this is what exactly we need to understand. Here NPR is nothing but R factorial into NCR. So formula for NCR, can you see this? NCR is nothing but NPR upon R factorial. What is NPR? You know the formula NPR. NPR is N factorial whole upon N minus R factorial. This is your NPR and this is your R factorial. Okay. So yes, I know that if you do a couple of problems only, na, then only you will be able to understand. Otherwise, you'll feel what is happening, ma'am, we are not understanding. Okay, to understand the theory better, you need problem. And to solve problem, you need theory. Huh? Are you stuck in infinite loop? How many of you feel that, ma'am? What is, I mean, in JEE preparation, I to feel that I am cooked. And I'm going to ask you, why, beta? What happened? And you are going to tell me, ma'am, when we go and try to understand theory, we need that, we feel that to understand theory better, we need to solve some problems. And when we try to solve problems, we feel, oops, to solve problems better in a nicer way, we need to go back and understand theory better. What to do? Life of a JEE aspirant. Theory, problem, problem, theory, problem, theory, problem, theory. But that's how it is. Both goes hand in hand, okay? Now, see, this is the formula. If you can see, this is the formula. Okay, NCR is N factorial upon R factorial, N minus R factorial. Okay, so here NC0. NC0, what is NC0? So NC0 is nothing but 1. Okay, what is NC0? Think about it. Think about it. Ma'am, NC0 is nothing but selection of 0 objects. That means selecting nothing out of n different objects. That means now you have 10 different chocolates. You ask your mom and you ask for 1 or I don't know how many chocolates you are convincing, but she's not getting convinced. She'll be like, okay, go get some chocolates. You'll be like, how many? So she'll be like, 0 chocolates. Okay, so there is just one way of not eating any chocolate, by not eating it. NC0 will be 1. Now you apply formula. You put R is equals to 0. You'll be like N factorial, 0 factorial, which is 1 by the way. And this is N minus 0, so N cancel 1. Selecting nothing, NC0. And you know what? NCN. If in the market there are N different options available, okay, and you need to bring 10 chocolates. And now your mom is saying, okay, Bring whatever you want to, but do not bring anything which is like repeated. Dairy milk, if you are bringing, only one dairy milk you can bring. So you'll be like, okay, I'll pick one chocolate of each. That's the one way. Selecting all the things at once, NCN. Now, NCN is also 1. Okay? All right? Now, understand. Properties of NCR. Properties of NCR. Understand. NCR is equals to NC N minus R. NC N minus R. NCR is equals to NC N minus R. What does that mean? Understand. NCR. Let's calculate what is NCR. Ma'am, NCR is N factorial, N minus R factorial and R factorial. This is NCR. Now, NC N minus R is what? N factorial, N minus N minus R. So, this is R factorial and N minus R factorial. Can you see both are same? Both are equal. So, NCR and NC N minus R is equal. That's the first thing. Now, understand. Suppose 10C4, it is equals to 10C6. Basically, this 4 and 6 should give you 10. Okay? So, understand, if NCR is equals to NCS, what does that mean? That R and S, if you add, you should get N. So, R plus S is equals to N. Okay? Or another way is both are equal, then also it is fine. R and S are equal, then so it will be equal only. That's so basic. But if they are not equal, then another thing will be N is equals to R plus S. Okay? All right. Yes. Chalo. Let's come back to, let's not talk about properties of NCR and into deep, because that we anyway going to study in binomial. But we need to first of all focus on what is NCR doing. This is a very good question to understand what is NCR. Very good question. Let's understand. There are 10 persons in a room. There are 10 persons in a room. Each person shakes hand with every person. 10 person in a room. Okay. So what is happening? Total 10 person are there and everybody is shaking hands with each other. Okay. Find the total number of handshakes. Understand, there are 10 person. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay. Understand, handshaking is not the problem. Think about it. When two unique person come together, when 1 and 2 is going to meet, 1, 2, they will shake a hand. Okay. Then 1, 3 will shake a hand. 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9, 1, 10. Then 1, 2. Then 1, 3, 1, done. Okay. Now 2, understand. 2, 1, I am not going to count it together because see, 1 and 2 already have shaken the hand over here. Now 2, 1 will be the same shake hand. That I don't want. I want unique selection of 2 people. That will be counted as handshake. It should not be like Taruna Kirti. Suppose I'll be like, okay, how many handshakes? I can shake hand with Taruna Kirti infinite times. No. 10 persons are there. If you have shaken hands with one person, why on the earth you're going to go again and shake hand unless you are doing some prank? Okay. So now it will be 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8, 2, 9, 2, 10. 2, then 3, 4, 3, 5, 3, 6, 3, 7, 3, 8, 3, 9, 3, 10. Okay. Then 4, 5, 4,6, 4,7, 4,8, 4,9, 4,10. 5,6, 5,7, 5,8, 5,9, 5,10. 6,7, 6,8, 6,9, 6,10. That's it. 7,8, 7,9, 7,10. 8,9, 8,10. 9,10. Count. 9 plus 8 plus 7. 6, 5, 4, 3, 2, 1. That will be the answer. Okay. So 9 plus 8 plus 7 plus 6. Okay. All right. Yes. So that is going to be 10C2. 10C2. Again, understand, this is a manual counting, but 10C2 means what? 10C2 means 10 factorial upon 8 factorial, 2 factorial. So this is going to be 10 into 9. 8 factorial, 8 cancel upon 2 into 1. So this is what? 45. 45 handshakes are possible. 45 handshakes are possible. Okay? Alrighty, everybody. Yes, this is how the combination works. 10C2. What is 10C2 doing? 10C2 is telling you that out of 10, how many unique selection of two things at a time or two people at a time can be done. Now, this is a question I want you to read and solve. Okay, and I'll be back in a minute. All right. 8 teams participate in a cricket tournament. If each team plays once against each of the others. Find the total number of matches. If each team plays once against each other. Have you calculated, everybody? It's very easy. 8 teams. Okay. So T1, T2, T3 and all the way up to T8. Okay. Now each team plays against each other. That means you need to find out how many unique selection are possible out of 8. See, T1 and T2 will counted as one selection, then T1 and T3 and so on. So that we have a tool. 8C2 will do this. 8C2 will give me the number of unique selection of 2 things at a time out of 8. So it is going to be 8 factorial, 6 factorial, 2 factorial. 8 into 7 into 6 factorial upon 6 factorial, 2 factorial. 6 cancel. 8 sevens are 56. 28. 28. Okay. Everybody is correct, I think. All right. Now the next question. Find the number of ways of selecting 3 boys and 4 girls from 5 boys and 6 girls. Again, not a very difficult question. Okay. So we need to select 3 boys and 4 girls. So 5C3. That means we are selecting 3 boys out of 5 boys. Okay. Multiply. Now 6 girls are there, but we need only 4. So it is going to be 5 factorial, 2 factorial C. By the way, let's do some direct things. 5 into 4 by 2 multiply 6 into 5 by 2. So this is what? 10 into 15. 150 will be the answer. Everybody? Yes? Okay. Next question. Okay. See, these are the concept building questions which you are doing with me now. Concept building questions. Find the number of ways in which a cricket 11 can be selected from 17 players. A cricket 11 can be selected from 17 players in which 7 can bowl such that team contains 5 bowlers. Okay. Number of ways in which a cricket 11 can be selected from 17 players in which 7 can bowl. See, and okay, so 17 players are there, 7 can bowl. Okay, all right, and my team, now cricket 11, now 11 players. First of all, see, I need 5 bowlers in my team. In my team, I need 5 bowlers. So 5 bowlers, but how many bowlers are available? Only 7. So first of all, 7C5, the bowlers are selected. So now I have a team of 5 people. How many more people I know? I want. So ma'am, 5 you already have, 6 you want. Okay. Now out of C, understand, 17 minus 5. Because 5 are gone, no? So 12. Total 12 people are remaining. I want 6 into 12C6. 7 into 6 by 2 multiply. Now 12C6 to 12 into 11 into 10 into 9 into 8 into 7 upon 6 into 5 into 4 into 3 into 2 into 1. Okay. That's how we roll. Now 2, this is 3. 6 and 2 cancel, 12 is gone. 5, okay. Now 4 ones are 4 twos are. So this is 5, again 2. 3 threes. This is what? 7 into 3, 21. Multiply. This is 22. And this is 3 twos are 6. 6 sevens are 42. if you're going to solve it, final answer will be what? 4410. Okay, 4410. Everybody? Yes, 4410, absolutely, Abhinav. Okay, that's how you solve the questions. Oops, it's 10c6. I have done something wrong. 7 can bowl. Acha. I was thinking कि 7 can bowl. So 17 minus 5 is 12. No, okay. Maybe this is something which I have done wrong. Oops. 17 can bowl, that means 10 can bat. Okay, so 7c5, now I need 10c6. This is correct. 7 into 6 by 2, and this is 10 into 9 into 8 into 7 upon. This is going to be 4, 3, 2, 1. So this is 3 2s are 6, and we have 4 and 2, 8 is gone. So 70 into 63, 4410. Now it's correct. Okay, now it's correct. All right. Okay, now the next question on your screen. Yes. No, actually, I was thinking. See, I am not a cricket person, but I thought that if out of 17, 7 can bowl, so I was thinking now I need 5. I need 5. 7c5 done. Now the 2 bowlers can bat also. It happens or not? Huh? In Indian team, who is the bowler? Bowlers can bat, no? Harbhajan Singh. I used to sit with my brother. He used to watch cricket, and I used to see that okay, Harbhajan is coming and doing batting. So I was thinking, okay, bowlers can bat. Bowlers are all-rounder. But then I realized, some bowlers are all-rounder. That's an exception. That means bowlers are different, batsmen are different. When we are not like, we are done with, when all the batsmen are gone, then only bowlers come into the picture. Oops. Major, I think I should start watching cricket. Okay, chalo. How many words with or without meaning? Each of 3 vowels. Each of 3 vowels and 2 consonants. How many words with or without meaning? Each of 3 vowels and 2 consonants. 3 vowels and 2 consonants can be formed. Okay. So I, O, U, E, N, V, L, T. Okay. So now understand, 3 vowels I need. So 4C3. 4 vowels I have, I need 3. Okay. And how many consonants I want? 2 consonants. So 4C2. So basically now I have 3 vowels, 2 consonants. Total how many letters I have right now? 5 letters. Okay. So selection is done. Now I have 5 letters. 5 factorial because I need to rearrange also. 4C3 is 4. 4C2 is what? 4 into 3. So this is 6. And 5 factorial is 120. So 12 into 12 into 2. 1440 into 2, which is equals to 2880 is the answer. Yes? Okie dokie. Everybody getting it? Chalo. Let's now talk about cards. Playing cards. Okay. How many of you are having that deck of cards? How many of you play cards? Huh? Ma'am, in previous question, we have 11 players. Pritija, you have not read the question nicely. We don't have 11 players. We had 17 players, out of which 7 can bowl. Now I need 11 players. I need 11 players. Okay. So now, first of all, 7C5. Out of 7 bowlers, I have selected 5 bowlers because the question is asking you to select 5 bowlers. Now you have 5. You need 6 more. That's how 11 is gonna be there, na? 5 plus 6. Now you have 5. You want 6 more players. Correct? So now the 6 more. From where you will select 6 players? The remaining 10. 17 you had, na? 7 are bowler. Discard it. Now 10 are remaining. 10C6. So total 11. Deck of cards. Okay. Now some people will be like, oh, some people will be like deck of cards. Okay. So now I want you all to play one game of cards today. And Diwali is also coming. In India, we have seen that in near Diwali, people play cards together. Okay. So deck of cards, if you do not know, I will show you that what exactly a deck of card, what all cards are there in a deck of card. First of all, there are total 52 cards. Total number of cards is 52. Okay. Now in 52 cards, there are 4 different categories. Those category we call it as suit. So this is suit. Suit number 1. Suit 1. Suit 1 is having, suit 1 is nothing but, so it is suit 2. Suit 3. Suit 3, this is diamond. Can you see diamond shape? Suit 3 diamond. And this is your heart. Suit 4 is heart. This is your club. And this is your spade. Okay. So now can you see 13 cards black color spade. 13 cards club spade. 13 diamond and 13 heart. Okay. Now I am going to ask you some questions. Tell me how many black cards, black color cards are there in these 52. So you'll be like, hold on, ma'am. We can see that the first row is having 13 black cards. Second is having 13 again black. So total 26 black cards and total 26 red cards also. Okay. Now each suit is having 13 cards. Okay. It starts with A. So every suit will have a single A. So suit 1 having A, suit 2 having A, suit 3 also having A, suit 4 also having A. Okay. Suit 1 having 2, 3, 4, 5, 6, 7, 8, 9, 10. And every suit is having 10. Now, this is JKQ. These are all face cards. Face cards. Can you see a face is there? Face cards. So, JKQ. Jack, Queen and King. Okay. Jack, Queen and King. So, now you tell me how many face cards are possible? How many face cards are possible? How many face cards are possible, ma'am? Face cards 3 plus 3 plus 3 plus 3. 3 4s are 12. 12 face cards are possible. Right or wrong? Okay. So, this is how the card says. Now, let's do one question to understand it better. Okay. We'll go back. If at all we are forgetting something, but we'll go back. Okay. Now, the number of ways of choosing 4 cards from a pack of 52 playing cards such that all of them are from the same suit. Oops. How many suits I have? See, you need 4 cards, but the condition is all 4 cards are of same suit. So imagine that you are having that 52 deck. Okay, and you have segregated also that 13 suit number 1, 13 2 suit number 2, 13 cards suit number 3, 13 cards suit number 4. 4 suits available in front of you. Now, you have to execute it. Okay, you have to choose 4 cards from one suit. So, you'll be like, first of all, ma'am, let me decide which suit I am going to select. Do I want from club or from spade or from heart or from diamond? So I have 4 options and I just want one suit. So select one suit out of 4. 4C1. What am I doing? 4C1 is selection of a single suit. Once you have chosen one suit, select one suit. Now you have, suppose you have selected club. Now you have to pick 4 cards from that suit. In that suit you have 13. So now you have a suit of a deck of 13 cards and you want to select 4 cards. So this is your answer. The answer is 4C1 into 13C4. Okay. Now understand, you have to select 4 cards where 2 are red and 2 are black. Okay. First of all, ma'am, 2 red cards. But total, how many red cards I have? 26 red cards. Out of 26, I want 2 red cards. And out of 26 black cards, I want 2 black cards. Are you getting my point? This is also done easy. Now you want to choose 4 cards and all should be the face cards. That too we just saw. How many total face cards are available? How many options are there, ma'am? 3 plus 3 plus 3 plus 3. 3 fours are 12. Total 12 face cards are available in 52 deck. 12. How many of you want, ma'am? 4. So 12 C4. But tell me, is it difficult? Is it easy? Yes? Tell me. Okay? Chalo, let's do one question. Let's do one question. Okay? There are M men and 2 women participate in a chess tournament. Each participant plays 2 games with every other participant. Okay. Everybody is playing game with each other. Okay. Total M plus 2 people are there, out of which M are men, 2 are women. Okay. If the number of games played by the men between themselves, okay, number of games played by the men among themselves is what? MC2 exceeds the number of games played between men and women by 84. Understand, MC2 is equals to 84 plus number of games played between men and women. Okay, so understand, I need between men and women, what do I want? I want one man and one woman. So MC1, so M, and one man I have to select and one woman I have to select. So that's how it is. MC2 is equals to 84 plus 2M. So M minus 1 upon 2 is equals to 84 plus 2M. Okay. So this is a quadratic equation. M square minus M is equals to M square minus 5M minus 168 is equals to 168 is equals to 0. Okay. So this is 168. Split it. It will be 2 into 84 and then 4 into 42. Okay. Then it will be 8 into 21. Okay. 8 into 7 into 3. 24 and 7. So it will be 7 2s are 14 and 12. 14 and 12. Let me check, huh? 12 and 7. Yes. Okay. 12 and 7. So it is going to be 7. Huh? Huh? Okay. 84, na? So it is going to be 2 into 84. Okay. Then 4 into 42. Then 8 into 21. Am I doing something wrong? Oops. Yes. Okay. Hold on. MC2. Plays 2 games with every other participant. Oh, the whole. Oops. I made a mistake. This 2 games I missed. No, each participant. So this is 2 multiply and this is also 2 multiply. Oops. I think I missed this 2. Okay, now 2 will get cancelled out. Now this is 2, this is 42, this is 2 also gone. So m minus 1 by 2 is equals to 42 plus 2m. So it is going to be m square minus m is equals to 84 plus 4m. So m square minus m 5m plus 84 is equals to 0. So now 84, okay, it is going to be just 4. 4 into 7 into 3. Okay, so 12 and 7. 12 and 7. 12 and 7 will be there. 12 and 7. So m is equals to 12 comma 7. 12 comma 7. So the answer could be what? 12 and 7, right? So m. Sorry, minus 7, right? 12 and minus 7, and this is going to be minus, yes, not plus. Minus 12 and minus 7. So minus 7 is rejected, 12 is accepted. Option A is absolutely right. Okay? Yes, Anjali. Yes, Muhammad Ashraf. Absolutely right. Okay. Now, let's talk about this very interesting method, which is Fevicol method, or you can also call it as box method, or also you can call it as string method. String method. String method. String method. Okay? Alright. Which says that find the number of permutation of the letters of the word random such that vowels come together. When the question is asking you to keep two specific things together, or the question may ask you that 2 specific things should not come together. 2 or more. So 2 or more specific things should or should not, should never come together. Come together. Then only this method will be useful. Then only this method will be useful. Okay. So now vowels come together. So A, O. That's it. 2 vowels are there. After that we have R, N, D, M. So now Fevicol method says that whatever you want to keep it together now, just stick them together using Fevicol. So it will be 1. AO will be counted as 1 letter because now we have stick together. Okay, so this is 1, this is 2, this is 3, this is 4, this is 5. Total 5 letters are there now. So it can be done using 5 factorial arrangement. Okay. All right. And now understand. Okay. But A and O can shuffle among themselves. A and O can shuffle among themselves. So this is 120 into 2, 240 is the answer. Okay? Yes? All right, next. The number of ways in which 5 boys and 3 girls can be arranged in a row that all boys are together. So, Fevicol method. Fevicol method will come into the picture again. Whenever they say that all are together. So, what we will do is, we will glue these 5 boys together. Okay, 3 plus 1. 3 plus 1. So, 3 girls plus 1. So, 3 girls, total 4 factorial, multiply. Now, these 5 boys will stay together and they will shuffle among themselves. So, it is going to be what? 5 factorial. So, overall, this is 24 into 120 is the answer, whatever the answer is. If all the girls are not together. Now, this is something else. All the girls are not together, okay? So, all the girls are not together means total ways. Total minus when all the girls are together. You just don't want all the girls to be together. So, what you will do? Total minus when all the girls are together. When all girls are together. Total. 5 and 3. So, total is 8 factorial. 8 people are there. You have no restriction. Total means no restriction. 8 factorial minus when all girls are together. All girls are together. All girls are together. Okay. So, all girls are together means 5 plus 5 boys, right? This time boys are there. Plus 1. Because girls you have glued together and become a Fevicol. So, 8 factorial minus 6 factorial. And now girls can shuffle among themselves. So, this is 3 factorial. That's it. Done, 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 done. Yes, Aradhya. Yes, Charan. Okay. All right. See again. What did we do in this particular question? Understand, this is the principle of complement, or you can also call it as complementary principle, which says that we used complementary, number of favorable ways is equals to total minus number of what you don't want. So sometimes the question languages, this should not be there. Never together, all girls are not there. So whenever these type of language, the not language is used, the reverse language is used. Okay, always go for principle of complement. Okay, we'll do more such questions also. Okay. Now this is something which is different. Okay. See, understand, this is a proper full-fledged questions in which the language is exactly this. In JEE Main, you will find the same language. So please remember, when this language is there, the interpretation is like this, and in this language, Fevicol method is used. Now there is another method which is gap method. So many methods are there, but it depends on the language of the question. Okay. The number of ways in which 4 boys and 4 girls can be arranged, no 2 girls are together. Understand, no 2 girls are together is different, not all girls are together is different. Here we cannot use Fevicol method. Okay, here they do not want 2 girls, even 2 girls should not sit together. So here what we should do is gap method. Gap method. What is gap method? When you do not want any particular, like no 2 girls or no 2 boys together, and specifically these type of questions are asked gender wise only, that no 2 boys are together. So what will you do? Leave these girls, ignore these girls and think about boys. Just arrange these boys. So B1, B2, B3, B4. Arrangement, gap method. Gap method says that the condition, no, you don't want girls to sit together, just leave those girls and focus on boys. So you can arrange 4 boys in 4 factorial ways. Now, boys are right there. See, if you are a teacher and you know that in this class, girls are so pathetic. They start talking the moment they sit together. So you'll be like, boys, come here. You'll stand, you'll make all the boys stand in one row. And now you'll be like, okay, there are gaps in between the boys. So one by one, you will make the girls go in the gaps so that no two girls are together. That's how you will do. Same thing we are doing, no? Same thing. The way class teacher does, I will also do the same way. Okay, so now how many gaps are there, ma'am? 1, 2, 3, 4 and 5. Always there will be one more gap. If there are 4 things arranged now, there will be plus 1 gap. 5 gaps are there. Now 5 gaps are there, but you have to make 4 girls sit, or 4 girls is there. So first of all, you have 5 gaps, but you want 4 gaps only. So gaps will be selected. So 5C4. Basically, you just want 4 gaps, but 5 gaps are available. So first of all, select the gaps. Okay, it can happen that your girl will be 1, 2, 3 and directly 4. This gap will be empty. So B3, B4 will come together. Okay, there can be different scenarios of gap selection. So 5C4. So now you have 4 gaps, 4 girls and 4 factorial. So this is for gaps and girls. Gaps and girls. And this is for your boys. Okay, now boys and girls sits alternatively. Okay, here understand, this is not an alternate fashion. You might think that, ma'am, same thing is happening now. No, hold on. Can you see what I did? Girl, then boy. Okay, see, understand. This is not alternate. Girl, boy. Okay, then girl, boy. Girl, boy. Boy, girl. I am keeping this gap empty. Is this alternate? No. Is this allowed? Yes. Because here 2 boys can sit together. No, girls cannot sit together, which are not there. But in here, boys also cannot sit together and girls also not sit together. So what will happen? You'll be like, okay, B1, B2, B3, B4. First of all, 4 factorial girls are there. Sorry, boys are there. Okay, 4 factorial boys are there. Now, you have 2 options. Either you start from the beginning, girl 1, girl 2, girl 3, girl 4. That's it. Or what you can do is you can start from here, girl 1, girl 2, girl 3, girl 4. So basically you have 4 options only. The 4 okay, so this is 4 factorial into 2. What is into 2? It depends. You want to start off with girls. Okay, so this arrangement will be girl, boy, girl, boy, girl, boy, girl, boy. Okay, and this is what? Boy, girl, boy, girl, boy, girl, boy, girl. Ma'am, they said no 2 girls should sit together, so I can keep another 2 girls sit together. Hey? Pritija, are they telling you which girls? No 2 girls should sit together. That means overall 2 girls cannot sit together. Basically, girls cannot sit together. What about another girls? In your class, you go to the school, right? If there is a rule that girls' washroom is different, boys' washroom is different, okay, this is the rule. Will you come and ask, okay, can I go to boys' washroom? Why? Because that girl will not go, I can go. No 2 girls. This is a generic statement. No to any girls, basically. It's just that 2 females should not be seen together. Is it very difficult to understand? Okay. The Hindi version is 2 लड़कियां साथ नहीं बैठ सकती हैं. No two girls can sit together. I hope you are understanding now. Mohammed is asking, ma'am, why you are taking C? Why not P? Huh. Because we are doing selection and then arrangement. There are conditions, no? There are conditions over here. You will never see me doing questions by doing just P. Okay? So basically, I don't use P. I don't use P. See, this is nothing but, this is directly, if you just, this is nothing but 5P4. You can use if you want, but I told you now, I always use C and then I arrange. Select and then arrange. Step by step I do. Okay? Yes? Easy to understand. That's why. Chalo. One homework question I will give it to you. One homework question. Similar, ditto, same. It's just that now the number of boys and girls are different. Okay, this is a homework question to you all. Homework question. Okay, homework question. Chalo. Let's see this question. Find the arrangement of the letters of the word permutations such that all the vowels has 1 unit and all the consonant has 1 unit. Ooh, good question, good question. Permutation. Okay, let's first of all, first question I am doing it over here. P, E, R, okay, M. Oops, not M here. M, U, T, A, T, I, O, N, S. Okay? Understand. Now, all the vowels are 1 unit and all the consonants are 1 unit. Okay? So now there are 2 units. Fevicol methods. All the vowels should come together. All the consonants should come together. So 2 factorials. But you can arrange the consonant among themselves. 1, 2, 3, 4, 5, 6, 7. 7 factorial upon 2 factorial. This is consonant. Then vowels 1, 2, 3, 4, 5. 5 factorial. So this is nothing but 7 factorial multiply 5 factorial. This is the answer of first question. Yes? Okay. Second question is very important. This is given in your NCERT also. There are always 4 letters between P and S. P, S. Okay. So what we are going to do is, first of all, permutations. Can you see this is 7 and this is 5. Total 12 letters are there. 12 letters are there. Okay. So 12. Now 12 minus P and S. So there are 10. 12 minus 2 is equals to 10. Now 10 are there. Out of 10, I want 4 letters to be sitting in between P and S. Ready? Yes or no? Agree? So it will be 10C4. I am selecting 4 letters and making those letters sit over here. Okay? So that I have a entity or a unit of 6 letters. This is a 6-letter thing. Okay? And you know what? P and S can interchange among each other. P and S can switch. Because I just want 4 letters between P and S. Now, so this could be S, this could be P. Then also it will be like, okay, it will be going as per the question. So into 2 factorial just for P and S switching. Okay, into 2 factorial. Now, this actually is a unit. This is a unit. You can't shuffle among, P and S cannot go in between. So this is the one thing. Total 12 letters were there, 6 letters are already there, 6 are remaining. Or you can say 10 and 4 are gone, not 6 are remaining. Now 6 more you have. So 6, now 6 plus 6. So 6 plus 1, 7. Can you see 7? Okay, 7. So this is going to be 7 factorial upon, but, here is the thing, because you have 2 factorial, because double T is there, no? So this is a tricky question, but it's a good question. It's a good question. Is it not? 10C4 into 4 factorial. So 7. Okay. Into 4 factorial will also be there. Okay. So the answer would be what? Let me solve it a bit. Let me solve it a bit. So it is going to be 10 factorial by 6 factorial. So 10 factorial by 6 factorial. 4 factorial cancel, 2 cancel, into 7 factorial. So this is going to be what? 7 into 10 factorial will be the answer. Right or wrong? 7 into 10 factorial. 7 into 10 factorial. Yes, 7 into 10 factorial. Final answer will be 7 into 10 factorial. Okay. Final answer will be 7 into 10 factorial. This is correct. Absolutely correct. Okay. Okay. All right. Let's move on to the next problem now. Okie dokie. Yes. The number of permutations of the letters of the word hexagon such that, oops, this is a new concept. See, today we have learned so many good things. I mean, so many important things as far as JEE Main is concerned. Okay. So let's try to understand one more pattern. The number of permutations of the letters of the word hexagon, relative position of the vowels and consonants are not changed. Relative position of the vowels and consonants are not changed. Okay, understand what they are trying to say. Okay, so understand that hexagon vowel is at second position, fourth position and sixth position. Second, fourth and sixth. That means vowel can shuffle among each other. Okay, so E, A and O, these three things can shuffle among 2, 4th and 6th position, and that can be done in 3 factorial ways. Now the consonant, 1st, 3rd, 5th and 7th, 4 factorial. So this is 144. Okay, 144. All right. Yes. Relative position of vowels and consonants are not changed. Okay. Order of the vowels is not changed. Now this is also very interesting thing. When order is not changed, I will give you a trick also. Basically what they are saying is H, E, X, A, G, O, N. Order of vowels is not changed. That means E will be coming first, A and O. Okay, the position can change. But understand, E, A, O. Whenever you write any word, E should come before A should come before O. Okay, not necessarily that they should come together, but E cannot come after A in that particular word. E should come slightly immediate before, slightly before, but it should come before, basically. Okay, so the trick is just make these 3 letters identical. Suppose this is H, even X, E2, G, E3, N. Basically what I'm trying to say is these three should be identical. How will you arrange now? Ma'am, 1, 2, 3, 4, 5, 6, 7. 7 factorial upon 3 factorial. So whenever order you have, you don't want to change the order of any, you do not want to disturb any order, no? What will you do? You'll do just shortcut, okay? This is a ninja technique. You can call this as a ninja technique. Ninja technique. Ninja technique. Otherwise, there is a long way. Okay, can you see? I'll show you the long way also. Long way says that let us arrange the consonant in 7 places. Okay, so consonant in 7 places. Consonant and so you have 4 consonant. Consonant arrangement you will do because vowels order should not change, no? So it will be 7 consonants are there. 4 consonants are there, 7 position are there. So this is 7p4, or you can do 7c4 into 4 factorial also. Okay, either 7p4 or 7c4 into 4 factorial. Now EAO can be arranged only in single way because they cannot shuffle, order cannot be changed. EAO, so just 1. So the answer is what? Tell me. 7 factorial upon just 3 factorial, which is equivalent to the ninja technique which I just told you, that make those 3 letters identical and boom, you are done. Okay, all right. See, the number of permutation of n distinct things in which the order of r things does not matter is n factorial upon r factorial. Direct formula you can apply. Okay, just like this. Okay, this is a very good question. Very good question. Okay, this is the last question because now I have to rush towards the next class. The number of ways in which Indian team 11 players can bat if Yuvraj wants to bat before Dhoni and Pathan wants to bat after Dhoni. Okay. See, understand. Yuvraj wants to bat before Dhoni and Pathan wants to bat after Dhoni. Okay. By DP. So Yuvraj, not immediate after. So why DP? So order should be, the order of Yuvraj, Dhoni and Pathan should be like it is actually before the retirement of Dhoni. This question was made before the retirement of Dhoni. Okay. So 11 factorial upon what? Tell me quickly. 11 factorial, number of ways in which if Yuvraj wants to bat before Dhoni, okay, and Pathan wants to bat after, correct. So 11 factorial upon 3 factorial. That's it. Done. Okay. Shall we take one more question? How many different 9-digit numbers can be formed from the numbers 22, 33, 55, 888? So that odd digit occupies even positions. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Odd digit occupies even position. What are even positions? 4 even positions. Now 4 odd numbers are also there. 4 positions. It is going to be 4 factorial upon 2 factorial, 2 factorial. 4 positions are there. 4 odd numbers are also there. 4 factorial upon 2 identical, 2 identical. Okay. Now, so that odd digits occupy even position. Now 2, 2, 888. The remaining 5 digits are there. So this is how it is done. That's it. Okay. Yes. Easy peasy. Not very difficult. Yes. Now from here we are going to take in the next session. I've got to go. Okay. Chalo. So what I'll be doing is I'll be taking your leave. This is me or Ninja Ma'am signing off, and make sure you attend the next session.